Hello. Good morning, everybody, or afternoon, or whatever it is, wherever you are. We are here, well, Ted, Joe, myself, we're all here to talk to you today about core development and the roadmap and, what we're thinking about for the future, how we plan it. And we also have a pretty, I think, exciting announcement for later that we'll get into in a minute here. But, as you may know, the Urbit Foundation has taken over core development as of this year. We've become sort of the primary driver of improvements to the Arvo kernel and everything associated with that, as well as the runtime there. And this all kind of began when Ted joined us at the end of last year, I think in October. And the first thing that he did was publish a roadmap. Now, this had never existed before for Urbit. They're just, things happened. People were happy about them. And if they were hanging out on the network talking to core developers, they might know what was going on. But otherwise, there wasn't really any way to know what was being worked on and what was coming up, unless you were, putting in the effort to pay attention and figure it out. And so the roadmap, just having a list of everything that was planned, everything that we knew that Urbit needed in order to become as useful of a system as it has been promised to be, having all of that laid out in one place was really valuable. Now, prior to us taking this over, Urbit was really, for a very long time, it was something that was built by Tlon. And Tlon was really the only organization that actually cared about what was built when, because they were the only ones using it to build anything. And so the development process was very much sort of driven by the people in the room that were using it. Over the last couple of years, things changed. There have been other companies that now have, are really betting their future on the maturity of Urbit as a platform. And they have wanted more insight and more input and more, more weight in figuring out how that roadmap evolves. At the very least, they've wanted to know, how do you determine what goes on to this thing? What do you prioritize and when and why? And I think the way this has happened, and not exclusively since the Urbit Foundation started doing this has been, I think, the case for a while. But especially in this last year, the things that are on the roadmap are not purely just the things that we think need to happen. They are determined in conjunction with conversations with lots of people in the ecosystem. We're on calls every week with developers at just about all the different companies, and we are pretty receptive to what needs they have. We know what's being talked about in different groups. There is a pretty good back and forth on different people providing input on what it is that they want to see added, what problems they need solved. HTTP caching, for instance, that went out in the last release was very much driven by Terrell's needs to serve content to the clear web. Remote scry had been in the works for a very long time. So it wasn't purely motivated by this, but we knew that the team at Akbar really needed it. And so that played a role in determining to prioritize it as soon as we did. Demand paging is a really important feature for hosting providers because it cuts costs down, which is a big part of the reason that we put a lot of focus on it early in the year, as it was clear that it was getting ready to come to light. But all of that, all those discussions have happened generally privately. You wouldn't know that they're happening unless you were actually in the conversation itself. And we have done our best to be pretty open about having those and have those conversations in places where people could take part in them. But there's a limit to that kind of knowledge transfer. And so what we want we want to do is make these conversations more public, make it the case that people know what we're thinking about when we're thinking about it, why we think certain things need to happen, and to really be able to enter into that conversation in a way that I think people have come to expect in an open source project that is held in trust by as many people as Urbit is. So what we're excited to roll out today are Urbit improvement proposals, or UIPs. If you've been around other projects like Python or Bitcoin or Ethereum, which is sort of the chain in which our own system is inspired by, you're probably familiar with this mechanism, which involves making pretty consistent documentation in the form of proposals about things that improve a protocol, and placing the process for moving that through the stages between draft and review and acceptance and implementation, something that is publicly viewable with, I think, like canonical documentation that places that improvement at a point in time in a format that people can understand how to integrate with it. And so I think this is like the next logical evolution in our effort to work in public to take that decision-making progress or process and, you know, put it out in the open. Yeah, so that's where we're at. In fact, we have a repo for this. Let me go ahead and put a link in so you can go check it out, and I can put it up on the screen and just sort of, you know, prove to you that this is in fact a real thing. Yeah, so we will share that, and then Sam, can you share my screen? There it is. Okay, it's a repo. It looks like a lot of other ones like this. It's inspired by EIPs. We've even gone in and added a couple of first improvement proposals that you can go and see and get sort of a reference for. We expect to see, you know, a lot more of these soon, and are going to be really adopting this process in the course of doing core development by making sure that all the changes that we do going forward that, you know, should warrant a UIP are actually done in this way. Now, if you're newer to the Urbit community, you may not know, we can go ahead and take this screen share down. You may not know that this is an old idea that predates my involvement in the project. There was an attempt a while back to actually do, I think they were called UPs, Urbit proposals. Ted, Joe, I think you guys remember this.
Yeah, I wrote several.
Yeah.
Yeah.
Why don't we, you know, what happened? Why wasn't that a thing?
Well, it's interesting because I think so the whole UP proposal system was launched, it was either 2018 or 2019. And a bunch of people wrote proposals, including me. I think Joe, I don't know, did you ever publish any of yours, Joe, or were there just notes?
No, I have some drafts. I still have some draft UPs, but I never actually published them, which probably speaks to the level of priority that was placed on this, and sort of just the degree to which it was real.
Yeah, exactly. So I think there was some attempt made to incorporate UPs into the development process, but it was never made an organizational focus of Talon. And I think that it was actually just right at that time not to have those be the primary focus. The community was very small. And yeah, as you said, Josh, all of the apps on Urbit were all Talon apps. And so you know, the core code, that platform was only being used internally by other code written in the same organization. And so there was some, you know, this was an experiment to try to sort of engage in a more traditional open source kind of model for development. But yeah, the company wasn't really ready for it. maybe the community wasn't ready for it either. And so what happened was those UPs kind of sat around and were never kind of made the cornerstone of the actual process for determining what happens, what gets built. So we're in a very different situation now, right? Because now there are many companies and just individual developers who are building Urbit applications. So, and also now the UF, the organization that manages core development, is separate from any of those. And so now there's a real separation between, okay, we have, we're working on the core, and then there are also all these other clients of the core, right? All these applications that use core features, core functionality. The ecosystem is also much bigger in general. The number of people on the network is much higher, almost 100 times bigger, something like that. I mean, it's a lot bigger. And then the number of companies and developers writing Hoon and building Urbit apps is also much higher. And a lot of those people who are writing Urbit apps have gotten somewhat involved in core development. Some of them gotten very involved in core development. So, now there are maybe just over 10 to 15 full-time engineers working on core. But then the number of people who have contributed some to core in the last few months is higher than that. So there are, so at this point, the mass of development is moving outwards, getting more and more distributed. And so we need more and more coordination between all these different groups. And we have to make sure that at the UF, we have to make sure that we're responsive to the needs of the community. So there's some things that, as core developers, we see what's happening with the system. We know kind of things like what was part of the original design that hasn't been built yet, and we just need to finish it. There's a lot of that kind of work. So that's work that's sort of sourced internally, where we know, just because we've been staring at the code for a long time, a lot of things that need to happen to that code to make it better. But then there are a lot of things that aren't like that, where someone else has a need that arises in the course of their app development or in the course of their product development of their Urbit. And so that's where the UIP system will really shine. Someone can come in and say, hey, we need this feature to be added to core because we're using it for XYZ.
There's a really good example of this from yesterday that you may have seen if you were on wolref-podlex's talk yesterday afternoon, which was Lick, this new vein that is proposed by Mopfel, who does not work at the Urbit Foundation. He works at Native Planet, and he's been wanting a deeper integration with underlying hardware because, well, they build hardware. Surprise. And that whole proposal, Lick, was actually, it was run very much like a UIP would have been run if it existed, right?
Oh yeah, very much so. Mopfel wrote up a spec and presented that to the core devs in an architecture meeting. And he publicized the spec, and then we talked about, we kind of brought him into a meeting, so got everybody who was interested together and reviewed it and determined that actually we were not going to approve that spec. This was the first thing that he wrote was called lock, and it turned out there were some security issues with it, and among other problems. And so that proposal got rejected, and so then Mopfel came back and wrote another one. This one was called Lick, named after Richard Licklider, the ARPANET guy.
We need to make sure that the naming scheme behind veins is something that is adhered to in our UIP system. Anyway, aside, sorry.
And but that one addressed all the issues with the previous proposal, and so that one got approved, and now that's being developed and reviewed, and we're planning on releasing that in the next Kelvin bump, next big release. So yeah, that whole procedure would have been very similar with a UIP system, but that process of review, replacement with a later proposal, all of that would have been much more transparent. So even if you weren't already in communication with Urbit core devs, you could read that on the UIP repo and see, oh, okay, well, Mopful proposed this one that was rejected for these reasons, and then proposed this other one that fixed all the problems.
Yep. Yeah, I think that's maybe one of the more notable recent examples of something that really would have been run this way, but I know it's not alone. We've been hearing about, we've been hearing people ask for this throughout the course of the year, right? I think you mentioned Liam. Maybe he's on. Yeah, he's viewing. Who knows?
Could be. Yeah, I first heard this desire from Liam, #DibTux, in January, and he specifically wanted to have more visibility into how it is that the UF was prioritizing and determining what to work on and who should work on. And so yeah, then we've heard that was the first time that I heard that, and then I've heard it echoed a lot more in the last month or two.
Well, building on the earlier observation, right, of previous partial and effectively failed attempts to build a public proposal system for Urbit. Other than the growth in the ecosystem, which is a really important factor, the thing I think that is most critical to the success of the proposal system this time around is that core development has been re-centralized at the foundation. And it's a first-class concern. It gets a tremendous amount of attention, I'm sure. Most of you know there are these daily PR blitz meetings. There are frequent prioritization meetings. There are many people whose job is basically exclusively at this point shepherding core development. And that was not the case before, and really couldn't be the case before. The design of Tlon as the Urbit incubator was to execute this dance of research, prototype, implementation, maintenance, and product development all at once. And no one such concern could trump the others. And we're all here and Urbit exists, and I think that worked. But it was really in tension with this kind of this kind of open process. So I'm very optimistic that the time is right to do this for real.
And that's saying a lot, because you are very allergic to bureaucracy. So I think I feel like this is not unnecessary bureaucracy. This is probably the right thing for this point in time. Cool.
There are a lot of fields in this UIP spec. I will say. maybe more should be optional. We'll see.
There may be.
We can add a third one, and there's motivation and rationale, and maybe we can have reasons or impetus is the third one.
Yeah, that's right. Transcript of initial conversation in the Forge. Yeah. Okay, so UIPs. This is how we're going to figure out the roadmap. And another way of looking at why this is happening now for us is that we haven't actually been thinking that much so far this year about what we're going to do next, because we've been operating on this blanket mandate to clear the backlog. When we came into running core development at the start of the year, there were like 90, 100 open pull requests in the Urbit repo. There was tons of stuff that had been sitting there forever. There were a lot of those were really big things. Remote Scry was spec'd over 2 years ago now, and it was mostly implemented throughout the early part of last year. And it, among many other things, were blocked on release by what's known as the agents and clay work that Philip Monk did, that prevented releases from being tractable to execute in a way that was not going to totally screw up the network, from my understanding.
Well, to be clear, Philip's work was fixing that.
Yeah, that's what I mean.
It was not tractable before. Yeah,
it was intractable before. And Philip's work was to make that tractable so we could actually do releases in the first place. And in the meantime, there was a whole bunch of stuff that accumulated that just couldn't really get released because that work needed to complete, which wrapped up in December, if I recall correctly.
Yes, that was released in December.
Yeah. All right, so we came into the year with like, okay, hey, we can finally release again. Tlon also created this great release process that we inherited and have run with, made minor modifications to, but has worked pretty darn well. And what we've been doing was like, okay, well, there's all these things that we really want to get out the door. We know they're needed. Now they can actually get out the door. Let's just get them all out the door. And so the year has been very much like, okay, well, we have our big list. Let's just work through it and see how much of this we can get out. We're at the end of that. Like the light at the end of the tunnel is here. Remote scry is out. We've burned down a huge amount of these, long-standing PRs, especially all the urgent ones. There's one big lingering one, which is user space permissions, that is under pretty active development right now, and I expect will, is within the next month or so before we'll really be talking about getting it out. Missing anything? Is that about right so far, Ted, Joe? All right, cool. So now we're like, okay, well, we can start to decide what it is we're going to do. And UIPs are going to be how we signal what we're deciding, how we gain support for those things, how we allow other people that have needs like Mopfall with Lick to bring their ideas to attention. But we do have our own roadmap. We have a direction that we want to go in and an area that we want to really grow Urbit in. And I think correct me if I'm wrong, guys, but I think that the sort of the biggest, like the overarching way to think about that, at least in my mind, is realizing the ideal of the global namespace. This is this aspect of Urbit that has been here from the beginning. The global namespace is talked about in the white paper, in some of the earliest written material about the system, in the very early demos that Curtis did. And all of this revolves around scry. We've called this scry maxing, the tongue-in-cheek earlier in the year. And what we have right now in Urbit is sort of this pale shadow of what scry and the global namespace could be. Ted, Joe, what is the global namespace and why should anyone care?
At this point, I think I've said it so many times that I should not say it again. And I think, Joe, you should do it.
Sounds good.
Oh boy.
Yeah, it's strange because I actually think the system itself is quite simple, but I found it difficult to convey to people in a way that's easy for them to grok.
Yeah, the system is quite simple. It's once you immerse yourself for half a decade in Urbit thought,
it's really simple. Why don't you get it?
Even. So the basis of the global namespace is Urbit ID. Right? Urbit ID establishes a global namespace. That's fundamentally what it does. There's a set of identities and cryptographically attested, discoverable, communicable, and so on. And the basic building block, or no, the basic mechanism or even intuition of the scry namespace or the Urbit global namespace on top of Urbit ID is simply that each identity should publish any data that they want to publish uniquely identified by a path rooted in their name. And so, sort of at the first level of analysis, the global namespace is, a global virtual file system where all the root directories are Urbit IDs. And any file that is available, discoverable through this virtual file system, is completely immutable. The binding between the file name, the fully qualified path, starting with the ID, and the value can never change. And mostly that just sounds inconvenient, right? When you're not thinking in those terms. It's like, well, you just took my file system and you broke it. What's the point? What's the point of a file system where you can't change anything? And the answer is simply that, the absence of this immutability is sort of the root of all the evils of the web. When things can change, when the mapping between a name and a value can change, you never know if you have the latest thing, right? The name doesn't actually name the value. It names some notional space of possible values changing in time or something like that. And you have to build additional mechanisms and doodads and protocols and to synchronize and figure out if you're talking about the same thing. And if you can collapse that all the way down to a path, which you could also think of instead of as a file system, you could just think of this as the web and think of this as a URL, right? The value published at a URL can never change. Then, you're very clearly over the target of the famous two hard problems in computer science, right? Which is cache invalidation and naming things. You've completely solved cache invalidation. Cache invalidation is simply cache eviction. There is no point at which a cache becomes invalid, right? The mapping from the name to the value, the cache key to the cached value, is always correct, right? You just might not want to keep it anymore because you're running out of resources or something. You still have the problem of naming things, but the namespace, the design of the namespace constrains you, right? It starts with your Urbit ID. And the rest of that then is basically, a question of aesthetics or ergonomics. And so this is all very, very abstract, obviously. But those two problems that are solved are concrete. They come up all the time. They affect most domains of distributed programming and affect them dramatically. Once you have data in this namespace, once you are able to get it and keep it, maintain it properly in this namespace, then interacting with it becomes incredibly ergonomic. At the network level, any intermediary node between you and your destination can resolve a request for you in this namespace. In effect, it turns your entire network into a CDN. And then in the sort of the most concrete terms as relates to Urbit, interacting with the namespace of a ship is stateless, right? So Urbit is this, deterministic event reduction model, and each event, produces a new state, and there's a total order over the events. You have to log the events. The Urbit computational model, the stateful Urbit computational model, is incredibly onerous. But reading from it can't change its state, and so there are no formal implications to reading from it, which means that you can trivially parallelize it. You don't have to write anything down. And this pattern of reading from an Urbit ship basically solves all the asymptotic problems of communication between ships. If you're communicating statefully between two peers, you're sending messages to each other. Each of you have to write down, the messages that you want to send, the acknowledgments as they come back. The scaling factors are brutal. The model has all of these nice transactional properties, but it's incredibly onerous. But if you're just reading as in a pure function from each other, you only have to write down what you hear. And so
An external client doesn't even have to write it down.
And an external
If you're
client
not-
doesn't have to write it down.
If you're not running a full Urbit as the thing that's retrieving the data, then if you have some external program, then maybe you retrieve the results, use it in memory, throw it away.
So I think, what made this really start clicking for me is when, because I'm a little more of a product guy. Like, what are the kinds of things that become unlocked from an end user's perspective once this system is actually in place? And you might also answer from a developer's perspective. I think, that's actually already been talked about a good degree. It's like the system becomes much simpler, much more performant. You end up with better ergonomics for doing things that are currently extremely finicky and annoying to build, like subscriptions. But as a user, and what kinds of things would I then have? And as a developer, what kinds of things can I build that right now are perhaps not viable?
Well, let me start on the sort of mundane side of that. So a lot of people now develop applications on Urbit and they distribute them. And the pattern that has become established and sort of blessed for doing this is to spin up a dedicated moon to serve as the public distribution center for the software that you're publishing. And the reason for this is simply due to network load. If you publish that from your daily driver planet, your planet will not be very responsive because it is going to spend lots of its time, anytime you publish an update, just simply, churning through the network packets and all of the formal responsibilities that they entail to distribute that data. And that's sort of a hilarious anti-pattern when you consider it from a high level view, because the data that you're distributing there is trivial, right? It's usually a handful of source files, maybe a couple of megabytes at the most, but probably hundreds of kilobytes in many cases. And right, the whole topology of that interaction is just hilarious. And so if those interactions are factored appropriately, right, your reads are reads and not writes, then it's no sweat off of your main ship to distribute it. You won't even notice that it's distributing it. And that scaling dimension should continue effectively arbitrarily. There is no intrinsic scaling limit on those properties other than the throughput of your network card or something like that.
Yeah. So if you're a developer, I can now officially distribute an application. If I'm Tucker Carlson, I can now officially distribute, a 10-minute video clip to 50 bajillion people or however many watch that, right? It's the same kind of thing, right? Arbitrary content now becomes viable for me to distribute to mass audiences without incurring some kind of stupid load.
The same pattern is true for group hosts, right? Where you tend to put the group host on one ship and then the channels spread out across different ships if there are many busy channels in a group. And it's for the same reasons, right? It's just simply the processing load of servicing those subscriptions. And so we should probably be clear about what exists now and what exists in the future. We did just ship FINE, a remote scry networking protocol. It is clear text and subject to some significant restrictions right now. And so it's basically suitable for publishing public data, static public data. So it's great for OTA updates and certain limited types of application metadata.
So I think about it kind of like it's the first step in this whole arc of getting to a more fully fleshed out version
yes,
of Scry
exactly.
and global namespace.
Right. But the destination here is you know, a global pub sub system where subscribers do not, there is no linear scaling factors on the publisher due to the number of subscribers. Subscribers do not take a lease, they do not formally consume resources on the publisher. Allowing someone to subscribe to you incurs no, you know, obligation on your part as a publisher. And then, yeah, we really are, at that point, we will be suited for, you know, viral groups, viral content creators, you know, massive asymmetry, right, in the topology of data dissemination over the network and that sort of thing, while still being a true peer-to-peer system.
Yeah, I'd like to clarify that a little bit, because a lot of times when people hear peer-to-peer, they think of distributed hash tables, Kademlia, torrents, blockchains, all of which involve this sort of amorphous sea of nodes where you have lots of different nodes. They're all sort of fungible. They're all storing either exactly the same data or, you know, pieces of the same data. Where you might, you know, in a torrent, maybe you have different nodes that store pieces of a file and they're all collaborating.
But that's opaque.
To serve that.
You know, it's like it might as well be amorphous because you're not really concerned with which pieces together they're a whole. You know.
Yeah. And so a lot of people, they think, oh, peer-to-peer doesn't scale because those systems don't scale. Because if everybody has to talk to everybody, yeah, that doesn't scale very well. And so a lot of people think, well, P2P doesn't scale, and so Urbit doesn't scale. But Urbit is not P2P in that way. Urbit is not everyone talking to everyone. It's very much not that. By default, one Urbit is communicating with one other Urbit. And, you know, until the remote scribe protocol was released, that was the only form of communication that Urbits could engage in with each other. You could just send commands to each other and acknowledge them or reject them. That's it. But, you know, it'd be the rovnys-ricfer ship speaking just to the master-morzod ship and hearing a response just back from that. And so fundamentally, Urbit should not impose scaling limitations on networking. All right, unlike some system where you have to distribute each piece of information to everybody. And so the Scry namespace is one of the major ways that Urbit can get out of the way, where the system can, you know, avoid being a bottleneck on resource usage. And so, yeah, we have seen this already with remote Scry. That protocol, I made what felt like a bold claim at the time before release, saying that this would cause a 100x increase in data download bandwidth from a single ship. I was really hoping that would turn out to be true. You know, I'd done some back of the envelope calculations and thought it was somewhat conservative, but you know, you never know until it happens. And sure enough, now there are measurements, and that number was, yeah, we've at least hit that, maybe even more. We don't know exactly what the limit is now, but it is at least 100 times faster than the previous system. So that's the first step, right? Is getting there. That doesn't have any kind of caching on intermediate nodes. It doesn't have any parallelism. And yeah, it's limited in a lot of other ways. But even just that first step, now part of the system goes 100 times faster. And so this arc that we're on right now of Scry maxing involves increasing the number of modules within the system that can use this protocol for distributing data to get that scaling benefit and also get the ergonomic and correctness benefits that Joe was talking about, right? Because it's a stable piece of data. You have a name that refers to the same piece of data eternally. And So that makes things like synchronization between two ships much easier to get right. But yeah, so we're going to add encryption, so you can have encrypted remote scry, distributed encrypted data, and keep the same scaling benefits, which is an unusual feature to have actually. Most encrypted systems don't have that kind of scalability. And then also make it so that one ship can request something that doesn't quite exist yet from another ship and be notified immediately when that piece of data exists. And that way you can use this for subscriptions. So if I want to hear about a live updating stream of data from you, I should be able to use this protocol, and so should all the other subscribers. And when that piece of data gets published by the publisher, it should immediately push it out as a response to all the subscribers who are subscribed. So we just started working on that. That's one of the initial UIPs called Sticky Scry. So there's a spec for that. And also we're going to extend scrying over HTTP. So your web browser can use this system to retrieve data. And then you can use all of the browser's caching facilities and server-side caching too. And there's several other improvements that we're going to make to allow this scry namespace to be used by more and more of the system until any time that one program in Urbit needs to do a read from another program, it should be using the scry namespace. And then that's when, so as that happens, fewer and fewer components of Urbit will be getting in the way for this kind of scalability.
And that effort, the way I think of it, it's sort of, it advances on two fronts or two kinds of fronts. At the lowest levels, there's lots of details to be worked out about the best way to route packets, right? And some of the details of the storage representations of data in the system at the lowest level. And then at the highest level, there are basically ergonomic questions, but they're big ergonomic questions because this really amounts to a different kind of application paradigm. It's like FRP, functional reactive programming, in some ways, and unlike it in others. And it's very different from, in some ways, it's very different from the kinds of, nested state machines that we have tended to build, which are functional in their internals, but effectively imperative in their sequencing and composition. And so there's much work to be done, at the lowest layers of the kernel and in the runtime, paving and finalizing and baking the design conventions of these kinds of namespace oriented protocols, whether that's over UDP or over HTTP, and how much can they share and how much do they need to differ, and these kinds of things. But then at the highest level, inside of user space, what application patterns comport best with this communication style, and possibly even more open-ended design questions of what an application is. And so the first step in that high level direction is the solid state subscription model, which has been prototyped. It's a real prototype. You can use it, but it's not currently backed by the namespace. It's backed by these command streams, conversational two-party command streams. And so there's much to be done in actually backing that by the namespace, actually figuring out how it can be used ergonomically, and then figuring out what what patterns that bubble out of that should really be baked into the application model, and that kind of thing can even, you know, possibly have implications for the Hoon language. And so those kind of two trajectories are, you know, how I conceive of namespace maximalism.
There was a question in here that was just answered about what happens in the namespace to the data in the namespace the public ship reaches. But this reminded me of an application for the namespace that I was going back and forth with you about a little bit yesterday, Ted, that I think is kind of cool and exemplary of, you know, things you can do with this that go beyond scaling. You know, scaling is a big thing, right? And it's obviously great to no longer have to give Urbit a minute and have everything be very fast, undeniably. But there is more to this than everything that we currently have going faster. There are new things that we can do that we currently can't. And where my mind went to was backups of important information, right? So like, let's imagine I've got my ship, it's running, it's in a hosting provider. I'm creating all this data, which is all just scribe paths. You know, it's scribe paths for every piece of data that is important to me under the hood. All of those paths immutably reference that information that is important. Call, you know, some kind of image that is stored in my ship, which is going to be a feasible thing next year when Ares is actually complete. But let's say I have some information that's really critical and I don't want to lose it, but I also want to be able to breach and not lose all my data. Like, the thing about scribe paths that occurred to me is that it doesn't actually have to be the case that I store all this information anymore. I can ask other ships to store that information at that scribe path, which is obviously mine because I signed it from a key that was mine. If I have to breach, say, you know, my hosting provider doesn't allow me to leave, I can't just pack up my peer. Well, I can breach, I can spin up a new ship, I can go ask every other ship that I have previously asked to store information for me to give me that information back. They know that it's me because my Urbit ID is part of that path, and they hand it all back to me, and I've recreated all of the things that were the most significant to me. And that can be redundant across many Urbit ships, I would think. This is sort of the same mechanism that you'd implement the CDN with, but with the application of, you know, now I'm able to just arbitrarily back up what information I want in a way that works for any data in any application because all the data is represented canonically the same way.
That's right.
All right.
And you could extend it even further by saying that you store the scribe data on some sort of external key value store. It could be basically anything. You take the path, you represent it as a string, and you take the value of that path, which is some Urbit noun, binary tree, serialize it, standard serialization for nouns, jam format.
Yeah.
And now, yeah, you could store anything that lives at a scribe path in any kind of system. You could use a very simple system for storing these, and you could read that back out. And so that would allow things like, you could have if you're running an Urbit hosting system, for instance, yeah, you might want a scribe cache that's global across all the ships that you're running. And yeah, maybe you pin certain values in there for backups. And then, yeah, if you, and this is where the sort of changes to the application model can come in, because if you had a different application model that's more functional and less imperative, we often call these kind of proposals a shrubbery proposal. And there are several different variants of these that we've been discussing for a while. But the basic idea of a shrubbery proposal is that all of the data that your user space app cares about is addressable at scribe path, which means that, yeah, you could take, you could sort of read all those scribe paths, copy them, store them anywhere you want, and then if you later need to reinflate those for any reason, you have everything that you need. And this may also make it easier to make sure that your app continues to work across, let's say, several Kelvin upgrades, right? Where if everything that your app cares about is available and there's structure to where the state is stored, right? A structure that's legible to, the Urbit kernel, other programs that may want to interact with you. Having data available at paths that encode a lot of metadata inside of them allows for a lot of these kinds of data sharing, reinflate data, build an application, right? Reproducible builds can be based off of this. That was one of the first applications of the Scry namespace, was a couple of years ago with software distribution to achieve reproducible builds on different ships, because all that data, all the source code and other data that can be used in a build, for a forward build for Hoon, if you're building an app or a library, anything like that, all that data is in the namespace. And then there's a pure function that runs on that data. So now you have data in the namespace, pure function that processes it. So now the output is deterministic as well. Right? So being able to string together these kinds of, and compose these kinds of deterministic computations, where you have knock running on data that's in the namespace, verifiable, shareable, cacheable. This is a very powerful paradigm for building a lot of different things. And this especially shows up in distributed systems, right? Because I was talking to Finmep Lanteb, who used to work at LinkedIn, and he and a few other people designed the LinkedIn recommendation system, recommendation algorithm. And one of the biggest problems they had, which is of course a big cluster, a distributed cluster, and one of the biggest problems they had was they eventually traced it down. Some pipeline kept crashing and getting the wrong answers and giving different answers. And it took them, I think, months to track it down. And they eventually tracked it down to a lack of determinism somewhere, where if something would crash and run again, then it would get a different ID number and would end up, with the result subtly changing. And because of that lack of determinism, the whole system ended up falling over. And this is very common with distributed systems, right? And this is why you see things like blockchains embracing determinism. But also, determinism for anything where you need many different nodes, many different programs to synchronize and share the same idea about what's happening, or what data exists in what places. That determinism is how you keep things sane, right? Because anything might fail. So, okay, run it again, right? Okay, well, if you run it again, it better do the same thing again, right? And so this, Urbit, of course, is a deterministic system. Each Urbit is a deterministic system. The network as a whole may or may not be deterministic, right? It depends on sort of how you look at it. And even just the fact that knock as a base layer is deterministic doesn't mean that in practice, the applications that you build preserve that determinism at higher layers. It's easy to lose it in practice. And so this is a lot of our job, is making sure that solid foundation, what we call solid state computing, extends upward through the stack, so that not only is it trivially or formally functional, deterministic, referentially transparent, but that those properties are also preserved in practice, so that if you go and write an application, you can use that very easily, preserve that when you write the app, and that those properties extend across the network, so you can predict how multiple ships will interact with each other, because the determinism extends up into the higher layers of the system across the network. So the scry maxing is a big piece of that.
Awesome. So we're in our last 5 minutes here before we're going to bring on a bunch of other core devs and have a bit of an AMA with those guys. So I think it'll probably make sense to not do Q&A in this session, since the entire next one is all Q&A. So I think, to drive towards conclusion, this is where our head is at, is making this Scry namespace into the best version of itself that it can be. The thing that it's always supposed to be, and we're in a position to, I think, really bring that about now. That brings scaling improvements. It brings developer ergonomics, and it unlocks new use cases for Urbit, many of which we definitely haven't even thought of at this point. And the way that we're going to prioritize these things is via UIPs. There's already a few of them in there. Sticky Scry is one of the first fall ones that's going to be worked on that extends remote scry capability to subscriptions, giving you the same sort of performance characteristics. That's sort of the prerequisite in being able to wrap solid state subscriptions or implement solid state subscriptions in terms of remote scry, so that subscriptions become both ergonomic to use and performant, if I remember correctly. And there will be a string of other ideas we have that are going to be added as UIPs, and you'll be able to weigh in on, basically see how we're thinking about doing these things now the implementations will work out. And during that process, every other developer, can also submit your own improvement proposals that we will consider in the regular course of all the rest of our development, because we're not the only ones that have a roadmap here, and we can accommodate, in fact, many simultaneous contributions to Urbit's roadmap. Anything else to add, guys, before we flip over to Core Dev AMA? Take that as a no. Cool. Okay. Well, I think we have Yep, I think so the next call is actually going to be on a different YouTube link, which is now posted in the chat. So bring your questions to the same group of people, sans me, and get into the weeds on some deeper stuff. So thanks, everyone. Thanks, Ted. Thanks, Joe.
Thank you.
Talk soon.
Thank you.
All right. See you.